starting from the top. In the quiet halls of the Fleet Air Arm Museum, an unassuming silver aircraft rests beneath the dim lights. To the casual eye, it might appear simple, small, slender, and strangely shaped. But this aircraft, the Handley Page HP.115, was anything but ordinary. It was a silent pioneer, a jet-powered whisper of what would one day roar across the skies as the Concorde. Back in the 1950s, the dream of supersonic travel was tantalizingly close, but riddled with obstacles. Scientists and engineers faced a paradox. To fly faster than sound, aircraft needed narrow, sharply swept wings to cut through the air at Mach speeds. But those same sleek designs were dangerously inefficient at takeoff and landing, precisely when control and lift mattered most. At the Royal Aircraft Establishment, two brilliant aerodynamicists, Johanna Weaver and Dietrich Kiemann, had an idea that defied convention. They discovered that delta wings with extreme sweep angles, could generate powerful vortexes at high angles of attack, boosting lift dramatically during slow-speed flight. This revelation was a breakthrough. It suggested that a slender, highly swept delta wing could make supersonic flight practical without needing monstrous engines or impossibly long runways. But theories needed testing. Initially, plans were drawn up for an unpowered glider to explore these ideas, but the logistics proved costly and complicated. A new decision was made: build a self-powered jet aircraft, a flying laboratory to put the theories through their paces. Handley Page, one of Britain's most experienced aircraft manufacturers, was selected to take on the challenge. In their Cricklewood factory, the HP.115 began to take shape, an experimental machine with a single-seat cockpit and a wing like no other. Its wings were long, thin, and raked back at an astonishing 75 degrees. The aspect ratio was incredibly low, just 1.3, making it resemble more a dart than a traditional plane. It was powered by a single Bristol Siddeley Viper 9 turbojet, producing about 1,640 pounds of thrust, modest by today's standards, but more than enough for its lightweight 2,640 kilogram maximum takeoff weight. The aircraft's airframe was tailored to study airflow, not break speed records. Its modified biconvex airfoil, with a maximum thickness just 4% of the core, mimicked what would be used on future SSTs like Concorde. Pneumatically operated air brakes, split flaps mounted at mid-chord, allowed precise control during slow-speed testing. Its plywood nose section was designed to be swappable for different leading-edge profiles, though this feature was never used in flight. On August 17, 1961, at the hands of test pilot J.R. Johnny Allen, the HP.115 lifted off for the first time. It wasn't fast, it didn't climb particularly high, but it did exactly what it was meant to. It validated one of the most crucial aspects of delta wing aerodynamics. Over hundreds of test flights, the HP.115 danced gracefully at slow speeds and high angles of attack, demonstrating the stability and lift predicted by Kiemann and Weaver. Alongside the HP.115, the BA-221 aircraft explored the high-speed end of the delta wing spectrum, forming a perfect tandem in the research effort. Together, they paved the way for the Concorde, which would go on to cross oceans in under 4 hours. The HP.115's cockpit was minimalist. No lights, just essential instruments powered by a small battery, airspeed, altitude, attitude, and direction. A Martin Baker ejection seat was installed for safety, though thankfully never used in an emergency. After over a decade of tireless testing, the HP.115's job was done. In 1974, it was retired and placed on display, its mission complete. Today, visitors to the Fleet Air Arm Museum may walk past it without realizing they're looking at one of the most important experimental aircraft in British aviation history. It never broke the sound barrier. It never entered service. It never carried passengers. But without it, the Concorde may have never taken flight.